Hello, everybody. Welcome back to the second part of today's lecture. And we're going to start with inference to the best explanation. Now, this is something that Darwin himself used when trying to propose the idea of evolution, right? He couldn't prove it, and so he was inferring what is the best cause for the effect that I'm seeing. Well, if I look at an engine, a car engine, the best cause for a car engine is going to be the car engineer, right? And all of the manufacturing people and now the robots that help assemble that car engine, right? That's the best explanation. If I found a car engine on Mars, or we found it tomorrow, there was a car engine, we would assume a mind put it together. We would infer that is the case. Okay, so I know from my personal experience, right, that integrated systems programming comes from intelligent individuals like us, humans, right? I know this. I have not observed evolution or natural selection and random mutation writing integrated systems level programming directly, right? And as far as I can tell in the laboratory, the best that we have seen is single protein, single enzyme function change. All other laboratory experiments that I am aware of, and there might be others, under controlled conditions where we can actually observe with a degree of clarity what is happening, don't show integrated system level programming coming from random mutations. So if I see integrated programming, actual computer level programming in a living system, and I know that humans can write that kind of programming, my inference is not millions upon millions of happy accidents, mutations, and natural selection climbing up my mountain probable to give me you or me, right, us. My inference to the best cause is going to be some kind of mind. Okay, because again, an integrated system, an operating system, comes from a human level intelligence. And the integrated systems in cells are at least as sophisticated as an operating system in a computer, if not vastly more sophisticated. This is the metabolic pool of reactions that occur in cells. And all of this is underpinned by integrated programming for every single protein in every single step. This is a very interconnected, interdependent system. This is not a happy accident kind of structure, right? This is not we mutated our way into it kind of thing. This is very much a sophisticated type endeavor. And so the question becomes, well, but can we really test for intelligence, Mr. Person here? I mean, that's not scientific. Inferences aren't scientific. Oh, okay. Well, I happen to know of a scientific program being funded by the US government that is testing for intelligence. It's called the SETI, the Search for Extraterrestrial Intelligence. If you can't test for intelligence, then there's no bother searching for it. So obviously you can in fact test for it. And so what is the test that they are looking for? The test that they are looking for is a steady spike, right? A single spike or a single signal spike that is stable and repetitive. So they are simply looking for stability in a radio signal as opposed to the random noise of the universe. That's all they're looking for, stability. That's the SETI test for intelligence. Okay, so, well, living systems have stability, right? The comb jellyfish has been around for something like 350 million years. Here's its fossil, and here's one today. This organism is morphologically, physically, basically the same, like 1-to-1 parts for the last 350 years. That's pretty stable, right? Oh, but you say the force of gravity is stable too, and maybe that wasn't designed. Okay, all right, so maybe stability alone, it's not a good test. And To be honest, SETI has been fooled multiple times now, where it has turned out to be a natural phenomenon that was causing a signal spike in a repetitive way that was very stable, right? So you would have something like a quasar was pulsing at a certain rate with a certain frequency. Or you would have a binary star system where when one star passed in front of the other, the signal changed, okay? Or a planetary object was so big it blocked out a star and the radio signal changed. So there were natural things that have been found that produced steady signals. So maybe that alone is not a good test, okay? Fair. That's fair. It's definitely fair. So what about complexity? Complexity is an interesting test. Jellyfish are very complex, right? You can see all of these structures. They're not simple. They're not a tornado through a junkyard set of conglomerations. They are rather sophisticated, engineered-looking type structures, very complicated. But crystals that you find also have very complex structures. So complexity alone is not sufficient. So stability is not enough on its own. Complexity is not enough on its own. Let's keep going. Specified complexity. This is a term that you should know. And this is the idea that the very specific arrangements mean something significant, right? It specifies. The complexity specifies something else. And so my Scrabbles, I can put my Scrabble pieces together and I can make things that are nonsensical, or I can have very specific chains of letters that mean something. That's specified complexity. Well, DNA definitely has specified complexity because every 3 digits, A, T, C, G, make a codon of those 3 digits, and those codons code for a 3-dimensional protein. So the code is specific to the protein, it's specified complexity. Okay, but maybe I can get some natural processes to make me the letter O, or the letter X, or some other kind of very specific thing that means something. So maybe I can kind of get away with this. I don't think that you really can. I think specified complexity is a decent test for being caused by an intelligence. But let's hypothetically say, yeah, natural processes put these rocks in a circle. They just happen that way. Specified complexity. This is an O. I'm going to propose one that's a little bit, it's kind of a derivative of specified complexity, but takes it one step further. I'm going to propose information category shift as a test, right? And so what do I mean by information category shift? Well, for example, I have a category of information, an actual dog. This is a 3-dimensional organism, can do all the things that a living thing can do, and I can represent that as DOG, dog. So this is alphabetic information that represents the concept or idea of a dog. It's a shift of information type. This and this are not analogous information. The idea is shared between the two, right? The idea in the letters is specified in the arrangement of the letters, gives you this information. What are some other examples? Okay, another good example is ASCII and binary. Okay, binary 1 and 0 is what is in every computer. Whatever device you are watching this video on is using binary to present the 3D image of moi, myself, my lovely person, to you. Okay, and it's using more than just ASCII. ASCII is a code of 1s and 0s to letters, but computers actually use 1s and 0s to 3-dimensional spatial and to color and to audio. So a lot more than just letters, but this is an example of an information category shift. Binary 1-0 to alphanumeric, right? ASCII. Well, DNA happens to have 2 categories. Our cells have 2 categories of information, right? Well, 3 if you include RNA, but I'm going to kind of jump the gun here. You have category 1, linear sequential, ATCG, or UACG, depending on if it's DNA or RNA, right? That's linear sequential, digital, to three-dimensional, structural, in amino acids, right? So category 1 is DNA, category 2 is amino acids, which fold into functional proteins. Okay, that's a pretty big category shift of information. Linear sequential, three-dimensional spatial, right? And that's a pretty big setup here. So I propose not just one test, not just two tests. I propose a 4-tiered test. It needs to be stable, like jellyfish have been stable for 350 million years. It needs to be highly complex, like jellyfish are highly complex. It needs to have specified complexity, right? It needs to have a code that is specific to a product. And it needs to have a category shift of information. Linear sequential programming to three-dimensional spatial end products. And a jellyfish has all 4 of these things. I'm not aware of, and I'm not God, so I don't know everything. I'm not aware of some naturally occurring thing other than a living system, other than a cell and higher, right up to us, that has all 4 of these, other than something that humans have made, like a computer, okay? The only analogous occurrence in reality that I know of that has that meets all 4 of these criterion is a computer program on a computer, okay? Or perhaps a car, something that a human has produced as a result of their mind. And so my inference to the best explanation from these 4 tests is that the jellyfish is the result of some kind of intelligent cause. Okay? That's my inference. Now, is a combined test enough? Well, I don't know. There are smarter people than me working on this problem. And there are highly motivated people who are staunch adherents to scientism, who are vehemently against the idea of an intelligent cause behind life, working hard to come across a solution to any sort of objection that I could possibly put forward. And with sincerity, I'm sure they're smarter than me, so they'll probably find one. So is this sufficient to say that life was caused by a mind? Probably not, okay? But it's a dang good start, right? I don't feel like I am intellectually bankrupt in any way, shape, or form, saying that, jellyfish, they are very stable over long periods of time. They basically haven't evolved or changed for 350 million years. They're highly complex. They have specified complexity in their genetic program, and their genetic program shifts to a three-dimensional spatial assemblage from a linear sequential set of instructions. It has an information category shift. I'm going to infer mind as a better cause to this than random mutation and natural selection. I don't feel like that is an intellectual stretch or somehow dishonest or disingenuous in any way, shape, or form. Right? So that is the end of this particular portion of today's lectures, and I will be back with some closing thoughts. Thank you so much for listening.